Today, let us look into a few more problems in interference. So the first question is, two waves have intensities in the ratio 1:9. Find the ratio of the intensity at minima to that at maxima. Now let the intensity of the first wave be I1 and the ratio with the intensity to I2 is given as 1 divided by 9, right? The ratio of the intensity at minima to that at maxima is to be found. Now intensity at minima is usually given as the square of the difference in amplitudes of these two waves. Okay, and intensity maxima is given as the square of the sum of the amplitudes of the individual waves. Okay, now for that we need to find A1 and A2. So from the given value I can write I1 by I2 is equal to A1 square plus A2 square is equal to 1 by 9. That is A1 by A2 is equal to 1 divided by 3, taking square root. This implies that 3A1 is equal to A2. Okay. Now, to find I minimum, I have A1 minus A2 the whole square. That is A1, A2 can be substituted as 3A1. So, minus 3A1 the whole square. That can be written as minus 2A1 the whole square. That is 4A1 square. Now, I max is obtained as A1 plus A2 the whole square. That is A1 plus 3A1 whole square. That is square of 4A1. 16 times A1 square. Hence, I minimum divided by I maximum, the ratio of minimum intensity to that of maximum intensity is obtained as 4A1 square by 16A1 square. That is 1 divided by 4. So from this we get the inference that the bright fringe is 4 times more intense than the dark fringe. Okay. In the next problem we have two sources of intensities I and 4I are superposed. Obtain the intensities in the interference pattern where the phase difference is given by A pi by 2 and B pi. Okay, so we have two waves. We need to find the intensity of the resultant wave when phase difference has two conditions. Okay, so first let us calculate the resultant wave. For that, we have the expression in terms of intensity as IR. Resultant intensity I is equal to I1 plus I2 plus 2 square root of I1 I2 cos of phi 1 minus phi 2. Okay. Now here I1 is given as I and I2 is given as 4I. So I can write IR is equal to I plus 4I plus 2 into square root of 4I square cos phi 1 minus phi 2. That is equal to 5I plus 4I cos of phi 1 minus phi 2. Now in the first case, when phase difference is phi 1 minus phi 2 is pi by 2, we have IR is equal to 5I plus 4I into cos pi by 2. Cos pi by 2 is 0. Hence, resultant intensity is 5I. Okay. Now in the second case, when the phase difference phi 1 minus phi 2 is pi, I have IR is equal to 5I plus 4I into cos pi is minus 1. That is 5I minus 4I giving I. Okay. So this is the intensities in the interference pattern where phase differences have values pi by 2 and pi. Now in the next problem we have two waves traveling along the same line given by y1 is equal to 5 sine of kx minus omega t plus pi by 2 and y2 is equal to 7 sine of kx minus omega t plus pi by 3. They are superimposed. Find the resultant amplitude, initial phase angle of the resultant and resultant equation of motion. Okay, so we have two waves y1 and y2. They are superimposed. We need to find the resultant amplitude, the resultant phase and the resultant equation of motion. So we have derived this same thing in the theory, but we had used A1 and A2 in terms of the amplitudes and phi 1 and phi 2 in terms of the phases. Okay, here the difference is that these values are provided. So let's do it. We have y1 is equal to 5 sine of kx minus omega t plus pi by 2 and y2 is equal to 7 sine of kx minus omega t plus pi by 3. According to superposition principle, we will have the resultant as the vectorial sum of the individual waves, that is y1 plus y2. That can be written as 5 sine of kx minus omega t plus pi by 2 plus 7 sine of kx minus omega t plus pi by 3. Okay. Now what we did was we considered the sine term as sine of a plus b, where a is kx minus omega t and b is pi by 2 or pi by 3 here. So expanding, we can write 5 into sine a cos b plus cos a sine b, that is sine kx minus omega t cos pi by 2 plus cos kx minus omega t sine pi by 2 plus the second term 7 sine of kx minus omega t cos pi by 3 plus cos kx minus omega t sine pi by 3. Okay. Now here we have the term cos pi by 2. Cos pi by 2 is 0, hence this term vanishes. It tends to 0. Here we have sine pi by 2. Sine pi by 2 is 1, so we will have this term. Here we have cos pi by 3. Cos pi by 3, that is cos 60 is 1 by 2 and sine pi by 3. Sine 60 is root 3 by 2. So substituting these values, we can have 5 times cos kx minus omega t plus 7/2 sin kx minus omega t plus 7 root 3/2 cos kx minus omega t. Now let us write together the sine and cosine terms. So taking the sine terms together, I have 7/2 sine kx minus omega t plus 5 plus 7 root 3/2 cos kx minus omega t. Okay. Now what I am going to do is substituting 7/2 as a cos phi and 5 plus 7 root 3/2 as a sin phi. Okay. So I am going to use the substitutions. I am going to write it here as a cos phi is equal to 7/2 and a sin phi is equal to 5 plus 7 root 3/2. Okay. So these two equations are 1 and 2. So this becomes a sin kx minus omega t cos phi plus a sin phi cos kx minus omega t. That is a into sin a cos b plus cos a sin b term that can be reduced to sin a plus b kx minus omega t plus phi. So this is the resultant equation of motion, but we need to calculate the values for a and phi. So earlier in the step we had written a cos phi is equal to 7/2 and a sin phi is equal to 5 plus 7 root 3/2. This was the first equation and this was the second equation. Taking the sum of the squared values of these two equations, squaring these two equations and taking its sum, we get a square is equal to 7/2 whole square plus 5 plus 7 root 3/2 whole square. Now calculating it, 49/4 plus, here we will have a term 10 plus 7 root 3 whole square by 4. That is, we can use the calculator. We get 49 plus 489.48 divided by 4. That is 134.62. Now we get a as the square root of 134.62, that is 11.6. Okay. Now taking second equation divided by first equation, we get tan pi is equal to 5 plus 7 root 3/2 divided by 7/2, right? Can be simplified as 10 plus 7 root 3 divided by 7, and that is obtained as 3.16. So tan phi is equal to 3.16. So taking tan inverse, we get phi is equal to tan inverse of 3.16. That is obtained as 72.44 degrees. The resultant equation can be written as A sine of kx minus omega t plus phi, where A is 11.6 and phi is 72.44 degrees. In the next problem, we have two simple harmonic waves acting at right angles to each other, and they have time periods in the ratio 1:2. Show that the resultant curve is a parabola when the phase angle between the two waves is pi by 2. Okay, so we have two simple harmonic waves acting at right angles to each other. So we can represent one of the waves with x and the other wave as y. So let the first wave be represented as x is equal to amplitude a1 into harmonic function sine of kx minus omega t, okay, plus phi. Okay, and the second wave is represented as y is equal to a2 sine of kx minus omega t plus phi. Okay, now let us differentiate between these two waves. We have two waves acting at right angles, so we have used one wave to be in the x coordinate and the other wave to be in the y coordinate, y axis. And they have time periods in the ratio 1:2. Okay, so that time period varies by a factor of 2. So let us take the wave x as the one having twice the period than that of y. Okay, so we have sine term having 2 times kx minus omega t. Okay, and we need to show that the resultant curve is a parabola when phase angle between the two waves is pi by 2. So here let the value of pi be pi by 2 and here let it be 0. So the phase difference is pi by 2. Hence x is written as a1 sine of 2 kx minus omega t plus pi by 2, and y is equal to a2 sine of kx minus omega t, right? Now let this be the first equation and this be the second equation. I am going to rewrite the first equation as x by a1 is equal to sine of 2 kx minus omega t plus pi by 2. Now look at this equation. It is of the order sine theta plus pi by 2. So what is sine theta plus pi by 2? It is cos theta. So this can be reduced as cos of 2 kx minus omega t. Right. Now this is similar to cos 2 theta. What is cos 2 theta in terms of sine theta? Can be written as cos 2 theta is equal to 1 minus 2 sine square theta, right? So 1 minus 2 sine square kx minus omega t. Okay. Now we have this expression here, y equal to a2 sine kx minus omega t. So sine kx minus omega t can be substituted into this equation as x by a1 is equal to 1 minus 2 times y square by a2 square. Right. Now we have a relation between x and y. So we have this equation. The question asked is whether the resultant curve is a parabola. Okay, so we know the equation of a locus for a parabola is given as y square is equal to ax, or y square is proportional to x, right? So we need to rewrite this expression in that form and verify we get it. So let us do that. For that, let us rewrite it into y square is equal to. Okay. So here I can write 2y square by a2 square is equal to 1 minus x by a1. That gives y square is equal to a square by 2 into 1 minus x by a1, or here it is a2 square. a2 square by 2a1 into a1 minus x. Okay. So from this expression, y square is equal to a constant a2 square by 2a1 into a1 minus x. We understand that we have a relation of y square proportional to x. Instead of plus x, it is proportional to minus x. So this represents a parabola. Okay. Now in this problem we have sources of intensities I1 and I2 are superimposed, so that the ratio of maximum to minimum intensity is found to be 25. Find I1 by I2, the ratio of the two waves, ratio of intensities of the two waves. So for that we are given Imax by Imin, right, is 25. Now Imax is actually a1 plus a2 the whole square, and Imin is a1 minus a2 the whole square, that is 25. Taking square root, I will get a1 plus a2 divided by a1 minus a2 is equal to 5. Okay, that is a1 plus a2 is equal to 5 times a1 minus a2. Rearranging, I can write 5a1 minus a1 is equal to a2 plus 5a2. Okay, that is 4a1 is equal to 6a2. That implies a1 by a2 is equal to 6 by 4. That is 3 by 2. We need to find I1 by I2. That is I1 by I2 is given by a1 square by a2 square. That is 3 square by 2 square. That's 9 divided by 4. Okay. So we have done some basic problems in interference and biprism experiment. You can do more examples from your textbook for study and reference textbooks. That's all for today. Thank you.